So for assignment 10, we're going to generate the solid. We'll still have basically wireframe geometry to build from. We're going to start off with a rectangle 8 by 4, and then we can go to the center rectangle 1 1/4 by 5. Let's get those two pieces up. So I'm going to start with the levels. So this will be the wireframe. And let's go to a level 10, and I'll switch that to be my solid geometry, just so that I have those at the ready. And so when we go into the rectangle, said we were width of 8, height of 5. We're going to anchor to the center, and pretty much just like we do normally if we were just drawing the outside shapes, outside geometry. We'll stay with the with our wire geometry. So let's see, 5 on the width and 1.25. Quick double check. Okay, and I would like to do the rectangular shapes, but there's no rectangular shape that's going to set, and I forgot to accept that, so I get to go back. 8 by 5, make sure to hit the check mark and continue. 5 by 1.25 and set, and then we can hit OK. Everything as far as the offsets, 2 from 4 leaves 2, so 1 inch, 1 inch, 1 inch, and 1 inch. So with that many, we can go to the offsets. All right, so we're copying the geometry, distance of 1 inch. Select the side, and we'll just run through and pick those geometries. Okay, so that one's looking pretty good. All right, the holes then are 0.75 in diameter, and we would split the 7 in 2, divide it, get a 3.5, so diameter of 0.75. Center point then is 3.5, 0. That will give me 1. And then we're going to accept, and then go minus 3.5, 0. Let's go ahead and make it 0.75 and accept. All right, the trim, break, and extend then. Let's go with the divide, delete. And the advantage again is that I'm just picking everything that I don't want. So anything I need to make go away, we can just divide or delete it out of the mix. All right, then the last one was our chamfer entities, and it was 0.25 by 45 degrees, 4 places. So that looks good. We'll go with 2 geometries and go ahead and accept. All right, so I have my shape. Now at this point I do not have my solid geometry or solid menu active, so we right click and customize the ribbon. We can come over to the right side and activate the solids again. That will give me the tools. All right, and then let's go ahead with the extrude. And when we're still picking chains, so it's going to find the outside of the geometry. And if I rotate that over, I can see the preview. All right, we have to check for the thickness, so 1/2 inch overall. And we're going to create a solid body. It's going to stay with the extrude. And then if I reverse the direction, that's going to send it down. and then we'll go with 0.5. All right, so solid, except I did happen to put all of the wireframe geometry on the solid, so I jumped over to that one just a little too quick. So let's see, how do I want to get that back? Well, we could just reverse them and don't want to type up in the box. So come on, click. There we go. All right, so the reason I did that is because now that one's active. I can right click on it, do the set all, and its level goes to 1. No, it didn't pick. Either that or I had the one line picked. All right, solid highlighted. That's what I want. Going to level 1. And go ahead. So now I have one entity on level 1. I can hide my wireframe if I need to. All right. So the next one will be a cut. And I still want to select chains to extrude. And if I have the island, we're going to see if this will show it as a cut body. I want to remove that material down to the next level. All right, so that leaves the boss in the center. We could also, if we drew this going up, we could add boss and have that material go up, have the 0.25 go down, have the boss and the 0.25 go up. I still want to kind of maintain that that geometry. All right. So Alt-1 will get me back to the top. Staying with the extrude, then I'm going to select the 2 circles, and that's going to be a cut body. And then we can do the distance again, or we can just go ahead and tell it through all. So it opens up that geometry. All right, so at this point we should have one body. If the first go around playing with the solids, I did this as a separate, and then I had to do a Boolean operation where I added the boss to the base. And so if you end up in a situation where you have multiple bodies and you want to make them one body, that is going to be an add operation. All right, so I bring that up just what are our description? Construct a solid from combinations of 2 or more existing solids. All right, so for an example, I'm going to put a groove down through here that'll be optional, but give you an idea of how to build with that additional geometry. All right, so one more piece. 100 thousandths by 45 degrees on the holes, so a chamfer. So one distance chamfer. And notice we're starting to get the solid selection, so I want an edge. The edge, the face, and the body are all highlighted. Everything else kind of in gray in the background is not going to be part of our selection set. So I can grab an edge and an edge, which is in effect the same as picking the chain. 100 thousandths, and no tangencies, and not worried about the mitered corners. So we'll go ahead and accept that. All right. So I'm going to add another level. I'm just going to call this one the slot. Again, this is the optional geometry, more to illustrate how the Boolean operations work. So if I were to hide that that slot, we have basic prismatic shapes. So a cylinder, and I want to generate a solid. Let's see, radius 0.25 should work. And we're going to go along the x-axis. And selected side, sweep angle 360 degrees. Start at 0 degrees. Alright, so the base point, let's see, we had 5 inches, so let's go with a -1 inch in X and 0 in Y. Okay, not sure what it selected there. How about we just draw a line? Alright, so length, what do we say, 3 inches, or I was going to go 2 inches, and then the radius on the ends. And we'll lock that one in place. Alright, now I'm just getting butt nappy. Alright, -1, there we go. Get rid of my extra. And then back to the solids. We'll go to the cylinder again, radius of 0.25. Height should be 2 inches then. And we'll go ahead and lock those in. Going along the x-axis is going to rotate it. Alright, and didn't give me, well, it gave me a direction of both sides, so okay, well that would have been the one I was looking for behind the geometry, but 2 inches. Okay, now I'm not sure what I drew for my line. There we go. All right, there's one item on the slot, except I lost it. Let's go ahead and turn on the other planes. So under View, come back up and turn on the solids. There we go. So the cylinder, and then the 2 pieces of geometry. I still don't know where that other cylinder went to, but we have our geometry. So, all right. So I'm going to put a sphere, also 0.25 in radius. And if I can find the endpoints, this will be just standard geometry. Okay, so that makes the slot that I can generate with a ball nose. All right, so pretty much end up with the 3 solids. Let's go back into the layout levels. We'll turn on the solid level. All right, and then so the example of the Boolean operation is that we are looking for the target body. That's what we're acting upon. And then the tool bodies for the operation are going to be the sphere, the cylinder, and the other sphere. And I think I got all 3 of those. All right, we're going to remove the geometry. All right, so it's basically just subtracting it out of the shape. If we were to add it, it would put a little dome there. If we were to take the common, then pretty much everything goes away except for the little half slot or half geometry that we have as the overlapping. All right. So that gives me enough to get started. Let's go ahead and make sure that everything is on. And visible. Okay, the wire. All right, so same types of things that we do normally. We're going to transform. I want to move everything to the origin. So, okay, that wasn't it. Let's come back over and pick our sketch, and then clear the colors. All right. And then for our stock, well, we need to pick the machine. Somewhere along the line, let's just go ahead and save this. So A10. All right, so that gives me the basis of the geometry. And then I have to make some decisions. Since we have the ball end mill, I would like to talk about blending if we were to do a radius around the boss. So again, additional geometry that you don't necessarily have to go through. But if I'm using a 3/8 inch tool and then a 3/8 inch ball end mill, I'm going to have some kind of corner geometry, or I'm going to be stuck with whatever the end mill will go into that corner, or I have to do additional operations. So that's usually the question is, does that have to be a sharp corner? If I can put a radius in there, then that's going to be preference. All right, so option one is to go with a fillet, and we're going to fill it along that edge. And let's go ahead and make it a 1/4 inch fillet. All right, so I can go through and make that pick. The other thing is that if you do make a modification, actually, if you do make a modification, notice this is basically our feature tree that as our body, solid bodies tree, that as we're adding geometry, we can add or take away. If we go back into the original extrude for this sketch, and I make a change to that chain, I can update. So if the constant radius, if there was more than I really wanted to deal with, there it was, delete, then I can go back into that original geometry, go back to the wireframes, fillet entities, we're at 0.25. And make my selections. Okay, and then somehow that didn't update. So let's go ahead and look under the solids. Let's see, which one is it? Oh, so we'll just go ahead and regen all solids. And then by changing that sketch, instead of adding a fillet feature for each of the items, I just included in the original sketch that generated it and tell it to regen and add those fillets in from those values. Okay, so a couple of options to work from. And then back into the levels, we'll hide the wire. Apparently those did not make it, so let's make that one. Well, yeah, let's see. We have the visibility. Let's set all. And we'll run around and pick everything that didn't make it. And we'll put it in the select. Now the points, not too worried about the points. We could go ahead and put those on level 10 as well. So let's clear the colors. Something's still selected. All right. So I said one more for the fillets then is that we're going to do a constant fillet, and I'm picking for edges. So there's no find all of the connecting. So the downside here is that I'm going to have to select each one of those edges or each one of the faces to get that that fillet geometry in place. So go ahead and rotate over, make that selection. And 0.25 is a little big. I said I wanted to use a 3/8 ball end mill, so 3/16 will leave just a little bit of a flat, and we can go ahead and accept it. All right. So I can I need the wire on for just maybe the stock. We'll probably need it for the dynamic. So let's make one more. Since I'm just accumulating levels here, I'll make a stock level. And it is the current level, and it's shown, so the rectangle. And that way I can turn off the center, go corner to corner, and then accept it, and then I can turn the wire off. Okay. So I don't necessarily have to have that that stock sketch, but I kind of wanted to illustrate the difference between the different stock selections. So we're under the machine, into the mill. We'll go with whichever one you have set up, the default or the generic cause. All right, everything looks good, and we'll go through the standard. And at least that one's staying from my control definition. And then the stock setup. All right, so at this point, we started off entering the values. That's probably the most inefficient way if we have existing geometry. If I do the bounding box, then that's going to give me the opportunity to select those corners. And have all of those additional. So there's the 8x5, and this one's a little more, maybe a little more graphic. So the minus 0.5, if we gave it 625, if we're going to, oh, it still wants to be a positive. All right, so we still have to make that that adjustment. If I go to all solids, we haven't generated any surfaces. If I go to all solids, then it finds that we're 5 inches in Y, 8 inches in X, and has the Z of 0.5, so that one's fine. Let's see, selecting corners is what we normally would do. So from that point to, again, because we have the depth, I would pick the depth. I think I missed that on the bounding box. That's why it didn't give me the minus 0.5. And then if I go to all entities, it doesn't really matter how many of these that I have. It will gather up all the available solid bodies, all the available geometry, and we're going to end up with the same group. Yeah.
You're doing this on the dialog box. You have a rectangular. Why are you keeping a rectangular and not differentiating into solid?
Habit.
Okay.
If the shape goes to the solid, let's see what it picks. Yeah, it's kind of one of those. I'm so used to picking in the wireframe. Now, one thing that I noticed is that the solid stock was not selectable. So even though under the shape with the rectangular, and maybe once we go over to solid, it will be. And somewhere we should see some stock. So stock model. If we go through and set up the stock definition, I don't know that I'm that familiar with it. Like I said, kind of that you get into the same. Oh, it didn't stay. Get into that same same process. Oh, okay. So on the shape, if we had drawn another solid body to represent, then when we go in and selecting an entity, if I had a rectangular prism, I would be selecting that body. So since I don't have one of those drawn, and that is a habit that I do have in working inside of SolidWorks with the various CAM packages, is to draw the shape of the stock around the part and then pick it as the stock value. So basically that's what I was saying is if I took this and made it into a solid and it was a separate body from my geometry, then I could pick it as the stock by selecting that as an entity.
So almost doing it as reverse, rather than building from nothing. Rather than adding, say, from the wireframe to the solid, you're taking your solid and then adding your features.
Yeah, kind of.
Similar.
So let's go ahead and try that. All right, so change to extrude. We are creating a body, single operation, and distance of 0.5. And this is where I'm used to. I'm probably more used to the SolidWorks or the solid modelers, but we have a stop op, and then we pick up the separate solid. All right, so is that going to give me the opportunity to make it transparent or do anything more with it? Probably not too much. So we'll see what it does. We might keep it. We might not. If nothing else, we'll pick it as the solid. I go back and grab that geometry. It's pretty much keeping the same values, but now I have it as that solid. Now, if I can't hide that and it's covering up everything, that's model prep. So maybe under view. But I think it's going to do whatever I tell it on the wireframes. It's going to do to all of the bodies. So other than changing the colors, I don't know. There's not at this point. I'm not familiar enough with the process, or haven't wrung it out enough to say that that's going to be an advantage or disadvantage. So even from the solid, if we don't have those view opportunities, if I could make that transparent and not pick it every time or hide it, I'd be a lot happier with it. So I'm going to go ahead and drop it out. Not part of my workflow. That's it's one of those. Use it a little bit more than it gets becomes a little more mainstream or a little more accessible. All right, so I have some geometry. I have my stock set up. Let's go ahead and go through some picking. All right, so I wanted this shape of the stock mainly because I'm still kind of figuring out the dynamic milling. So a couple of the things that I want to see is we could do this as standard pockets, and pockets are going to be your the always go to. But as the dynamic milling becomes more more accessible, then we will we'll start using it. So as far as the facing operation, we'll come across. Let's see. All right, we do need to mention the feature-based machining. So let's go ahead and run through it standard, and then I'll do just a quick couple of operations with the FBM. All right, so facing has that same issue. Do I want to face just in the geometry that is going to end up being the face, or do I want to cover all of the material? Well, not really. I can go back to, since all of these are solid edges, the C-plane, the 3D, those really aren't going to help me. I need to switch over to solids. All right, once the solids are selected, then I can pick a loop. If we go to the face, well, the thing to keep in mind with faces is it's probably going to try to work around that slot. So let's just go with the loop, and it finds geometry. Other face would be, since I picked that line, there is a vertical face. It will allow me to try to pick that vertical face. So if for some reason that it did pick that vertical face, then it would allow it to switch. Okay, so that gives me my geometry. And the tool, let's stay with just the, I said a 3/8 flat end mill. And I think, I'm not sure what I set this machine up as. So let's see if it'll, all right, so since I set this up to run on the TM 4,000 RPM spindle, it's warning me that if I put anything over 4,000, and that's kind of an error checking depending on what machine you're programming to. All right, so I can enter 4,000, but any 4,001 is going to have that warning associated to it. All right, so I'm going to give it 2,000s per tooth. Nah, 32 is a little fast. 16 I can live with, and maybe 16 on the plunge. Well, this is a face cut, so pretty much just coming in on the geometry. We'll go zigzag. It can overlap. I'm not really worried about direction. No stock to leave on the floor. No depth cuts, and then our linking parameters 0.25, 0.2, and 0. I'm okay with all of this. So other than maybe changing how it reverses at the end, I'm pretty good on the face. So since this is about a whatever I decide at the machine, a 5 or 10 thousandths plunge, I'm not really too worried about the selection. So notice that instead of the chain geometry, we have the symbol for the solid, meaning that we selected a piece of solid geometry. Okay, so that's the top of the part. We'll go back in and pick up the dynamic mill. The machining region then is the stock. So this one I want to go back to the wire, and I'll just pick along the C-plane. There's no vertical to worry about, but if I'm in that construction plane, it just finds its way all the way around. All right, and then the avoid regions. All right, so I don't want to go into this, into this radius, or I want to be able to control how much I go into the radius. Then I have to switch back to the solids because now I'm picking an edge. All right, and so we're looking for that loop again. Loop finds its way all the way around. I verify that it has the correct geometry, and now we can set it to cut. Don't have anything really for error or containment, and not too worried about the entry, so we'll go ahead and set it. And with all of this additional information, I've now made it the habit of looking at the region strategy. I want to start from the outside, work its way in, let it go outside of that boundary. Tool is still the 1/8 inch. We were at 4,016, so I think that's still pretty reasonable. And another one that I haven't made part of my strategy is setting up the stock. So we don't really have any rest material or adjustments to the stock, so this is one I have to kind of start using as I get further into it. Climb, tip, first pass, step overs of 093, minimum radius of 037, gap sizes 500% of the tool diameter. I don't know about that one, but we'll go with 100. 10 thousandths lift difference or distance. Stock to leave on the walls. So we're overrunning the outside. But one of the things with those radiuses, since a ball end mill is technically not cutting at the center point, it's more of a drag. There's no, you'd have to have an infinite number of surface feet per minute because your radiuses or diameters are 0. So I usually want to overrun that wall by maybe 5 thousandths. All right, so, well, we'll try that again. So a negative value will allow it to cut into the wall just a little bit. So when the ball end mill comes in to blend, there's not a separation line there that it has to remove. And it's a very minor amount, but it's enough to help with the blend. And then notice it shows up in red, says you're going into your stock. Are you sure you want to do that? Depth cuts. And entry of the helix, that should be fine, no breakthrough. And then the depth we'll set by picking a piece of geometry and have the minus 0.25. All right, so anytime I have that solid, anytime I have that wireframe, I'm going to be able to click on depth and have it go into the geometry to make that pick. And what didn't it allow? I liked it okay. It was like just a pause. All right, so it goes around the outside, and I think what I'm going to find is I get this to the machine and actually see it cutting. Even at the 4,000 RPM, I'm going to be able to bump this up 24, 25 inches a minute, or instead of about 100,000 a step over, maybe take it up to maybe a third or 50% tool engagement. All right, so I want to duplicate this. I did ask about the copy and paste, and Tex reminded me that you can right-click and drag, and you will get a move before, move after, a copy before, and a copy after. So I think I'm a little more comfortable with the right-click and copy, and then right-click and paste. But if we copy after, that's going to be the same geometry. If I go back in, we're still starting from the outside. The machining region is still pretty much everything. The avoidance region, though, and pretty much like the chain, is I'm set to the loop, so I'm just going to delete the chain. Okay, let's just go ahead and delete the whole solid then. And we'll add a new chain in, and I'm going to have it pick up just to remove for those pockets. Okay, so have the same basic, should be able to regenerate. And I did not give it a new depth, so let's go ahead and hide. Do the control button there so I can hide the display. You can kind of see that it did what I intended to do, except for I'm still not sure why it wants to generate this one lone toolpath around the outside of the stock. All right, so even in that, it tells me that I didn't go back and completely finish that geometry. Also, with that 5 thousandths that I left on the wall, this would probably be a good time to say, no, I really don't want that to be a negative. I'm going to get rid of my negative there. And let's see, what else was I looking for? Oh, the depth. So I'm going to kind of jump around here, go into the depth, pick that one. And then the last one was in our cut parameters. We, we've done this operation, or we've done the dynamic mill a couple times. The motion, gap size, and retract. When avoiding a boundary or exceeding a distance, I think it was this one. Let's go ahead and see what that gives us. All right, so other than it kind of jumping back and forth, I still kind of wanted it to stay engaged and be able to go back and forth, but I just wanted it to make this rapid move across. So let's see what the next one does. All right, so that was a little bit more what I was looking for. All right, so I didn't leave any extra distance there for our geometry. So flipping this over, whatever, it's right on the edge. I would probably have a little piece of aluminum foil left over on the pick. All right, so for the profile, before we do this tool change, let's just do a standard contour. And I'm still in solids, so I want to make sure that I have the loop. We'll start on this corner. It finds its way around the loop. So one of the things in comparison with the chain, I do like the loop finds that solid geometry a little bit better than the chain kind of being able to reverse and do some strange things. It doesn't seem to have that same issue with selecting the solid loops. And I don't think I checked the rapid, but we'll let it rapid retract on this one. We want to include the wear, and we can check the direction, but yeah, let's go ahead and do that. I still want to go up to my geometry, and this is one of those cases where arrow's pointing to the inside. I'm in conventional on the outside, so my choices are still to reverse. All right, so that puts me to climb, but I really needed to change the side. All right, so climb and to the outside. So when I look at the cut parameters, this compensation direction left, that doesn't make near as much sense to me as still looking at those arrows and saying, I am on the correct side of the part. I'm cutting to the correct side, and I'm going in the correct direction. Lead-ins, let's go ahead and get rid of the inner exits, and we will extend. Let's see, that was the percentage. 3/8, we'll give it 0.2. Make sure that it has the ability to lead off. And the depth. And hopefully I picked something there. Okay. That was strange. I didn't transfer it over. So I need to get rid of the exit and the contour. There we go. All right. So we're a 3/4 inch. We can do those as a pocket. And let's go ahead and turn the display off on a couple of these. So standard pocket for the through holes. Still like the loop, and I do want to be a little more careful about the selection. Right, if I were to pick the top edge of the chamfer, that would be the diameter that it cuts to. Okay, and then our direction, it's a pocket, so everything should be internal. Same tool, not keeping my values, so this would be a good time to go into the tool definition and make these settings more permanent. All right, and then roughing, since it's circular, I think the true spiral. Entry motion, probably not going to get away with a ramp. Those look okay. Probably want a little heavier plunge angle. All right, and then finishing. Really just start finish pass at closest entity and go ahead and machine finish pass. I'm going to look at that tool and see what it's capable of generating. Tangency, the 0.375, that's a little on the large side. So let's shrink those up quite a bit. We're only in a 3/4 diameter hole, so that's going to be quite the overrun. Depth cuts, breakthrough, and if the incremental is 0 at that depth, yep, we have something that will lead in, make a pass, do the finish pass, and retract. Okay, good with those.
So why does it look like it's roughing both holes and coming back to each hole and finishing it?
Because it is. It is. All right, so there is a, let's go back and see if we can find it. Usually there is a bi-level, finish the outer boundary. Let's see, keep the tool down. No, that would not be good. After roughing all pockets, since this is only one level, that's probably going to do it. All right, so typically we would only, if we were stepping down 2 or 3 times, we wouldn't want to finish at every one of those levels. Now that we're just kind of plunging through and letting it finish, so yeah. So those lines are your key, being able to read and decipher what it's doing. It's still going to retract, move over, but I'm okay with that and can probably even find the keep tool down, but keeping the tool down makes me nervous here because in that other condition, if we'd missed that, keeping the tool down might plow through the center of the part. So pay attention to what you're getting for those rapids and those linear tool movements. All right, let's see. We have the 2 ball end mill. So let's go with a contour and staying with the loop. All right, so the nice thing is that's my depth, the 0.25 on our incremental. And so at the beginning of the semester, we stayed away from the incremental because that 0 depth is not as, I'm going to say, it's not as visual that when you're thinking absolute, I'm telling it to go an absolute minus 0.25 or minus 0.5 inch. And that becomes part of your habit. As you're selecting more geometry or more wireframe geometry, then the incremental is giving us those steps, and our value is 0 in relation to the geometry that we picked, to the chain that we picked. All right, so tool, let's go ahead and select library tool. We're going to filter for the ball end mills, 3/8 inch ball. Not sure I want to push that one quite as hard, so we'll back it down just a little bit. Cut parameters still has wear, no stock to leave, no stock on the floor. Still like the extensions, and then the parameters on the depth should be okay. All right, so what I didn't check for was my chain. Or actually the geometry. So arrows to the inside, and it's in conventional. So change the side and reverse the chain. And that's kind of a weird place to start. So let's see, analyze. Is it? Oh, the start point is grayed out. If we had access to the start point, I should be able to pick. So I'm not sure why that is on the solids, but I have to go back and look at that one. It's not a terrible place to start. It's just probably not first preference. All right, so that one looks like I went a little too far out anyway. So actually, I should have picked the top. Okay, so if we come back and I pick a little closer to that edge, see if that that gives it to me. And direction and location are okay. All right, but now because the depth wasn't set by the location, I could switch back over to absolute, but incremental in relation to the selection, minus 0.25. And then rebuild. Okay, and then we can do the same thing with the, and just kind of looking at where that blend is. You know, the end mill is going to take that 5,000, so I don't know that it's going to get that completely, but because the ball end mill is rolling around those edges, we do run the risk of having a little scallop, a little triangular scallop in those corners. We may have to take care of if it's noticeable, but you know, it's kind of one of those, just be aware of it so it's not a surprise if it shows up in the part. All right, so contour then. Let's go ahead and duplicate. I'm going to try and stay with the copies. All right, and clear. All right, so this chain is going to be just an edge, and the edge is grayed out. I don't want the entire loop. All right, so just from point to point. Don't even really need, other than geometry, and we're to the correct side. All right, so from that selection, 0.187, we can adjust accordingly. The other one is there will be no lead in, lead out. We plunge in, so that brings up another, I'm kind of working backwards through this on the logic. That plunge rate for the ball end mill, probably not going to be 12. Let's cut it in half, see how aggressive it is going into the material and feeding across, and then we'll come back and make our adjustments. All right, so it comes up and over, plunges into the center line, goes along. One thing with the wear and the compensation, I don't know if that was still on. I can switch back to computer because there's no lead-in, there's no movement before the start. It's not, the post really shouldn't include a G41, G42 because it doesn't have that linear move to engage it. All right, so what are we missing? The chamfer. All right, so we'll restart that one or regenerate that one more time. Let's go ahead and pick up a couple of the operations, turn off the display. Back into the levels. Still have the solid. Oh, not sure what that was on the slot, but okay. Oh, the stock was the other one. All right. And the last one will be a contour to do the chamfer. It's going to be an edge. I think I'm still more comfortable picking the lower edge. Tool geometry then, we're into the select tool and the filter. Pick up our chamfer mill, don't really need the ball end mills. 100 thousandths, that's going to be pretty close and quite heavy for a 1/4 inch. I don't think the ½ inch. I would still say load the larger tool into the program, and then if we need to, we could go out on the floor, grab a 3/8 or a 1/4 inch, and see what it does. It's still programming to the tool and the depth. So let's see, what do we want for speeds? Carbide chamfer mill should be able to take the 4,000, but I'm not going to get too aggressive on the feed or the plunge. And then the cut parameters, we're switching over to the 2D chamfer. All right, the chamfer width is 100 thousandths, and the bottom offset, maybe not. All right, so if I was going to use the 1/4 inch, 20, 25, 30 thousandths would be right there at the diameter. If we tell it to go 0.125 deep, it's going 0.125 over. All right, and depending on how much it programs for the offset, we're using every bit of that 1/4 inch tool. And again, there's not a lot of surface feet per minute going on at the tip, so we have more cutting action going at the larger portion of the diameter, and not so much at the tip. So we'll see what we get.
You wouldn't want to put your compensation on just in case you did need to swap out tools.
Yeah, you can switch it to wear, because then you can always run it in comp into the wall. You can also do if you have the depth, you can also do it with the height offset with the length register. I'll get it out. All right, 100,000s still doable, so I'm not worried about depth cuts. Lead in, lead out. We do want to turn those back on, and no, they're not going to be linear. Nice gouge into the part doesn't help me, so let's transfer those over, keeping them kind of small. No breakthrough, no multi-passes, no tabs, and then not sure. I picked up the 100. Actually, incremental on that one should be 0, but we need to see what we get. I'm not sure about that one. Go ahead and accept it. And I thought I picked a little bit higher up. So that's definitely not what I was looking for. So let's double check the chain geometry. So that one looks okay. All right, so chamfer width at the top. Well, that should already be set, right? It's sent in an additional, and bottom offset of 20 thousandths. There we go. All right, so if we pick the top, then it would move over the 100 thousandths and go down. Setting it at 0 says follow this edge and go down an additional 20. So that's pretty much where I have the most problem with the chamfer, is depending on what you're selecting, you have different combinations that you're dealing with. So it's verify that this looks close. Regardless of the operation, I'm probably still going to touch off this chamfer tool and raise it up, I don't know, 20, 30, 50 thousandths. Make a couple of test passes and see what it actually cuts out, how it looks. And then once I've set an actual depth for it, then stay with it. Same with if I was going to do the deburr edge breaks around this of 5 or 10 thousandths, is I would raise it up a little bit, and then in subsequent passes verify that it's giving me the right relief, the right chamfer after we do all of that. All right, so that's our solid geometry. There are some advantages to it. There are some things we're going to have to chase a little bit more. So let's go ahead and, well, I'll save first and then we'll simulate and see what we're looking at. So not much in the face operation, a little on the outside. I guess we could speed that up so we're not here all day watching it simulate. So a nice thing about that dynamic mill is it is leaving the tool engaged. Those minor movements, it's generating a lot more code, but tool load is going to be much more consistent. All right.